So good morning all my dear students. I'll be starting with the next part of your module 5. So this is entirely a different part. So in the first part, the previous part, part 1, I had explained to you about the joint probability distribution, correct? So the probability distribution part is completed, and the next part what I'm doing is entirely different. Okay, this is something called as sampling theory. So in your module 5, the very first question will be on which one? Joint probability distribution. So the joint probability distribution part was completed, and the next two questions will be related to sampling theory. Okay, so this sampling theory is a very interesting and a unique part which you study here in, and this will be the last part of your fourth semester engineering mathematics. Okay, so before going to the actual problems, we should know some of the definitions of sampling theory, and also here few definitions they will ask for 7 marks directly. Okay, once when it comes, whichever definitions are asked, I'll let you know, and make sure that you study it properly. Easily we can score 7 marks over here. Okay, so sampling theory, I'll first start with some of the basic definitions which are required here. So first thing, population or universe. See, normally when you hear the word population, what will come to your mind? You know, the group of people who are present in an area, that is known as population. Or we tell the population of India is this much and the population of China is this much, correct? That is population in terms of general. But in when it comes to particular, like for in terms of sampling theory, we tell that population is a large collection of individuals or an attributes or a numerical data. Okay, it neither be, it can be individuals, or it can be a group of people, or it can be a numerical group of numerical data. Together is known as population. Here we can see in this diagram, this together group of numerical data is known as a set of population set. Population doesn't mean that it should be always only the persons. It can be numbers, it can be items, whatever it is, we call it as population in sampling theory. Okay, next definition. Now sample, what is a sample? See, you know, during this coronavirus time, in your news you might have normally come across this word sample, correct? You know, the news anchor will tell you there are so many samples which have been tested for corona positive or corona negative. What is that sample? From a group of people, they'll select one person like who will be having a fever, and that person's sample they'll collect, right? What is that sample? You know, they will take something from the throat and they'll test it to check whether they have corona positive or negative. Same way here, in the sampling theory, we tell sample as a part of population or the finite subset of the universe. Okay, means we are selecting certain parts in the population or from the universe, that is nothing but sample. Okay, next, sampling. What is the difference between sample and sampling? See, sample means we are just selecting certain numbers here, correct? Sampling means how do you select these numbers, that is called as sampling. See here, the process of selecting a sample from the sampling is called as from the population is called as sampling. Got an idea? The how do you select this sample? Correct? If you have fever, then only we select this. That fever thing is known as sampling. In general, I am telling you. Okay, so the process of selecting a sample from the population is called as sampling. Okay, sample means just identifying. Okay, the process of selecting is known as sampling. Next, random sampling, and then sampling with replacement and sampling without replacement. What is this random sampling? So the selection of an individual or an item from the population in such a way that same chance has been selected, that some chance of being selected is called as random sampling. Okay, means randomly we are selecting some of the samples here from the population. What is this sampling with replacement? So this is nothing but where the member of population may be selected more than once. With replacement means what? We are selecting them and again we are replacing them, correct? For example, you might have seen corona positive patient who has been discharged is again found to have corona, right? That is with replacement. Like he'll be already having corona, he'll be cured from that, but again he'll get corona. That is with replacement. Without replacement means what? If a member of the population cannot be selected more than once, then it is called as sampling without replacement. If is not selected again for the test, then it is known as sampling without replacement. Okay. So these are some of the basic definitions. This they will not ask most of the time. If they ask, you can write it, I think. Very simple definitions. Okay. Next, sampling distribution. So this is nothing but how we distribute this sample. So for every sample n, sample size n, whatever we have selected, we can compute the quantities, means we can find the mean, variance, standard deviation, etc. Correct? Correct. When we have the sample, can't we find the mean and all? Yes. Suppose we have this group these characters according to their frequencies, the frequency distribution so generated is called as sampling distributions. Okay. What, you got an idea? Suppose we have the group of these characteristics, means the mean, standard deviation, whatever it is, according to their frequencies, then the frequency distribution here is called as sampling distribution. That's it. Okay. So the sampling distribution of large samples is assumed to be of normal distribution. You know, we normally use this normal distributions here, and the standard deviation of a sampling distribution is also called as standard error. This word is important. The standard deviation of a sampling distribution is always called as what? Standard error. Okay. Yes. So this definition is very important, and likely to be asked questions in your SEM exam as well as for the internals. Testing of hypothesis. So this hypothesis, whatever you select, how do you test the hypothesis, or the sample, how, whatever you have selected, how do we test it? So the testing of hypothesis here involves the two statements. One is null hypothesis and one more is test alternative hypothesis. So these hypotheses can look very similar, but they are actually different. Correct? For example, when we select a person, actually we have two hypotheses. Two hypotheses means what? One hypothesis is like a person may have corona. One more hypothesis may be like a person may not have corona. Correct? So these actually looks very similar, but they are actually different, right? Once when the test result comes, then only we'll come to know whether the person will have corona or whether he will not have corona. Same way here in sampling theory also, we have two statements here. One is null hypothesis and one more is alternative hypothesis. Okay. So now, how do you define this null hypothesis? So this is very important. This statement, whatever I have written first, you have to write it in a similar way when they ask you to define or explain. Okay. Null hypothesis. The hypothesis formulated for the sake of rejecting it under the assumption that it is true is called as null hypothesis. Okay. So I'll repeat again. The hypothesis formulated or the hypothesis generated for the sake of rejecting it, and this word is important, under the assumption that it is true is called as null hypothesis. Or the null hypothesis also reflects that there will be no observed effect in our experiment. For example, we might take this null hypothesis as this person is a corona positive person, but there may be no observed effect, means there may be no observation that he may be having a corona. Correct? That is nothing but null hypothesis. In mathematical formulation of null hypothesis, there will be a typically a equal sign. Okay, and this null hypothesis is denoted by H naught. The symbol is important. H naught, null, 0. That's why it is HO or H naught. So what is null hypothesis? This is a hypothesis generated for the sake of rejecting it under the assumption that it is true. Means we are assuming that this person may be this person is having corona, but for the sake of rejecting it, what we should do? He should get a negative report. Correct? That is nothing but null hypothesis. Also, if this null hypothesis is not rejected, then we must be very careful to say that careful to say what does it mean, right? See, null hypothesis is not rejected means we have to be very careful. If the person is if my hypothesis is that the person is having corona, assume that this hypothesis whatever you have selected is not rejected. Not rejected means he might get a positive result. Then what? Then we have to be very careful. Then the thinking on this is similar to a legal verdict. Legal verdict means we have to be very, very careful. Just because a person has been declared not guilty, it doesn't mean that he is innocent. Correct? Now this is an example of a judgment I am taken. Suppose you assume that the person is not guilty. That doesn't mean that he may be innocent. Correct? Right? We are just assuming that okay, this person is not guilty, but we cannot tell that this person is innocent. So in the same way, just we are failed to reject a null hypothesis, it doesn't mean that the statement whatever we have selected is true. Am I right? So this explanation we have to write it here. Proper? Yes? Okay. Next. Alternative hypothesis. What is this alternative hypothesis now? A statistical hypothesis which differs from a given hypothesis is called as alternative hypothesis. Means normally we will be having one hypothesis. What is that? This person is having corona. This is my hypothesis. If this hypothesis may not be true, then we might be having another alternative hypothesis. What is that? The person may not have corona. Correct? So that is what we are defining here. A statistical hypothesis which differs from a given hypothesis is known as alternative hypothesis. Okay? The alternative or experimental hypothesis reflects that there will be an observed effect for our experiment. Correct? In mathematical formulation, alternative hypothesis, there will be typically an inequality sign or not equal to sign, and the symbol is denoted by H1. Okay? Alternative hypothesis is H1, null hypothesis is H0. Also, the alternative hypothesis is what we are attempting to demonstrate in an indirect way by the use of our hypothesis test. If the null hypothesis is rejected, then we accept that the alternative hypothesis is accepted. Correct? If the null hypothesis is not rejected, then we do not accept the alternative hypothesis. Correct? A very simple example of coronavirus. You assume that the null hypothesis is that the person is affected by corona, and you assume that the alternative hypothesis is the person is not affected by corona. When will you come to know which is correct? When the test is done, and if the result of the test comes positive, then my null hypothesis is accepted. If the results comes negative, then my alternative hypothesis is accepted. Correct? Either this or that. That's it. Null hypothesis or alternative hypothesis. Got an idea? See, when you explain this in the exam, you explain it with the example, then only you will get marks. Okay? So I have few of the examples here. Few of the examples for alternative hypothesis and null hypothesis. So you see here, this is a diagram. My hypothesis here is effect of the biofertilizer, that is some biofertilizer on the plant growth. Okay, so I will be assuming my null hypothesis as H0 as the application of the biofertilizer X does not increase the growth of the plant. This is my null hypothesis. Correct? It may be true. If this is not true, what is my alternative hypothesis I can assume here? My alternative hypothesis, what I can assume here is the application of the biofertilizer X increases the growth of the plant. Correct? So always my null hypothesis is like the positive term what I should take. So my null hypothesis here, I am assuming that the biofertilizer X does not increase the growth of the plant. But here, if this is not true, what is my alternative hypothesis? My alternative hypothesis is that the application of the biofertilizer X increases the growth of the plant. When will we come to know which hypothesis is accepted here? When the experiment is conducted. So see here in this diagram, we can see this. There are chances that when you water it with the biofertilizer X, there may be chance that it will grow or it may not grow. If it grows here, then we tell that my alternative hypothesis is accepted. If it doesn't grow here, then we can tell that my null hypothesis is accepted. That's it. Very clear? Okay, one more example I will take here. This is one of the example. One of the basic, this example, how I came to know is like, I thought, okay, normally when I was reading one book, I came across this Copernicus scientist who said that the world is round, correct? So normally assume that this null hypothesis is that the world is flat, and alternative hypothesis is the world is round. See, initially when Copernicus was not there, everyone used to think that the world was flat. Am I right? If you know the history properly, this is what they were assuming. The world is flat. Correct? But once when the Copernicus did some experiment, then only we came to know that the world is round. Right? So that is what I have explained here. Just check. Several scientists, including Copernicus, set out to disprove the null hypothesis. Right? He tried to disprove the null hypothesis. What is my null hypothesis? My null hypothesis is that the world is flat. This eventually led to the rejection of the null hypothesis and the acceptance of the alternate hypothesis. Is it so? Yes. But I am telling you the but case. But most of the people accepted it, and the ones who didn't created the earth flat earth society. Correct? What would have happened if Copernicus had not disproved the hypothesis, null hypothesis, and merely proved the alternate one? What would have happened? Then no one would have listened to him. Correct? If this Copernicus, if he didn't prove this hypothesis, whatever we had assumed, the world is flat, if he didn't disprove it, what would have happened? Then we might have thought that the world is flat only. Correct? So in order to change the people's thinking, we have to first prove that their thinking is wrong. Thinking was wrong. Correct? So read this statement again. This statement, the last statement, whatever I put here, it is very much helpful in your life also. In order to change the people's thinking, he first had to prove that their thinking was wrong. Correct? Correct? So same way you can apply this to your life also. Okay? So this is one more example of null hypothesis and alternative hypothesis. Hope you are clear with this, my dear students. So this is one of the important definition what they will ask in the exam. Define or explain null hypothesis, they will ask. So when you explain null hypothesis, along with that you can also explain what is alternative hypothesis. Okay? Next. One more important definitions. Errors. So when it comes to error, whenever we conduct any experiment, we will be having certain errors. Correct? Right? Any experiment you conduct, obviously there will be some error. Right? So here also we have two types of errors. First see this, type 1 error and type 2 error. Okay? Type 1 error, it involves the rejection of the null hypothesis when it should have been accepted. Okay, means we have to accept the null hypothesis, but we are trying to reject it. That is my type 1 error. See, if this null hypothesis is correct, we have to accept it. Correct? If you are rejecting it, then that is an error what you are doing. That is nothing but type 1 error. So what is type 2 error? It involves the acceptance of the null hypothesis when it is false and it should be rejected. Are you getting an idea, my dear students? See, I will tell you again and again. Type 1 error. Okay, it involves rejection of null hypothesis when it should have been accepted. For example, my null hypothesis is that a person is having coronavirus, and it has been proved also. Okay, but still that person is not ready to accept that he is having coronavirus. Then that is an error. That is a mistake what a person is doing. That type of error is known as type 1 error. Hope you are clear with that. Okay, now what is type 2 error? Read this carefully. It involves the acceptance of the null hypothesis when it is false and it should have been rejected. Now same way, I am telling that first I will be taking my null hypothesis is that the person is having coronavirus. But when I conducted an experiment, I came to know that he is not having it. But many of the people who are staying around him are not ready to accept that he is not having coronavirus. That is type 2 error. Got an idea? What is it? Go through my wordings again and again, you will get an idea. Okay? Or then see this. So error, in the test process there can be 4 possible situations which lead to 2 types of errors. So what is that? If the hypothesis whatever I have selected is true, then we will accept a hypothesis or we will reject the hypothesis. Correct? So if the hypothesis is true and we are accepting it, then that is correct decision. Correct? Means if the person is having coronavirus and it is tested positive, then we are accepting it, that is correct decision. Suppose if the hypothesis is true, means a person is having coronavirus, but we are rejecting that hypothesis, means he is not ready to accept that he is having coronavirus, then that is a wrong decision and that is type 1 error. Got an idea? Yes. Now, suppose if the hypothesis is false, but still you are accepting the hypothesis. What is that hypothesis? My hypothesis is a person is having coronavirus. But when I conduct an experiment, I came to know that my hypothesis is wrong. Means a person is not having coronavirus. But still they are accepting that hypothesis. Then that is nothing but type 2 error. That is a wrong decision. Correct? As I said, a person is having coronavirus. That is my hypothesis. But when I conduct the experiment, I came to know that he is not having coronavirus. But what happens? His surrounding people, neighboring people, they will still assume that he is having coronavirus. That is your wrong assumption or wrong decision. That is my type 2 error. Correct? And one more possibility. Hypothesis is false. Rejecting the hypothesis, that is my correct decision. Yes or no? Correct? I came to know that he is not having coronavirus and his entire family and the neighbors will accept him. That is a correct decision. Means they have rejected the hypothesis. That is a correct decision. Got an idea? So this thing, everything should be written with an example. Coronavirus is the best example to explain all the definitions, my dear students. Okay? Yes. I have also done a table so that it will be easy for you to understand it. So just see here. If the hypothesis is true and you are accepting the hypothesis, then it is a good conclusion. Suppose if the hypothesis is true and your hypothesis is false and you are rejecting the hypothesis, then again it's a good conclusion. What are the alternative ways? Your hypothesis is true, but still you are rejecting the hypothesis, then that is type 1 error. Okay, your hypothesis is false, but still you are accepting the hypothesis, then that is type 2 error. Okay, the same way which I have explained in the table in the previous slide, same way you can also explain it in this way also. Left to you, choice is left to you. If you want to get good marks, you have to explain it in a more colorful way. Okay. So these are all about type 1 error and type 2 errors. Okay. So the two different types of errors which we come across here. Next, one more is significant level. Okay, this is purely mathematics related, my dear students. So here you no need to give an examples and all, you just go on explaining it. Okay. So what is the significance level? The probability level below which leads to the hypothesis is known as significance level. So this probability level is always fixed to 0.05 or 0.1, that is 5% or 1% level of significance. So the significance level we normally fix it. Okay, this is when we test no, we will be having certain level of significance, that is 5% level of significance or 1% level of significance. Therefore, rejecting the hypothesis at 1% level of significance implies that even at 5% level of significance, there may be errors of either of the type, either type 1 or type 2. Means their error may be 0.05. Okay. Next, how to test the significance and confidence interval? The process which helps us to decide about the acceptance or rejectance of the hypothesis is called as test of significance. Suppose that we have a normal population with mu and standard deviation sigma. If x bar is the sample mean of random sample n, then the quality t defined by z is equal to x bar minus mu divided by sigma divided by root n is called a standard normal variate. Okay, whose x bar is 0 and sigma is 1. Next. So then from the table of normal areas, we find that 95% of the area lies between minus 1.96 to plus 1.96. That is 5% level of significance. Okay, and therefore it is denoted by t of 0.05. 5% means correct, 2.5% on the negative side, 2.5% of the positive side. If your hypothesis, whatever you are testing, if it is between this value, between minus 1.96 to plus 1.96, then we can tell that the hypothesis is accepted. And if it comes outside this, means if the value whatever we test, whatever we get here, if it is greater than 1.96, then we tell that the hypothesis is rejected. That's it, very simple. Okay. How do we tell it? Means minus 1.96 less than or equal to x bar minus mu divided by sigma divided by root n greater than or equal to plus 1.96. Simplify it, go through the simplification steps, my dear students. Finally we get this, correct? Therefore the equation 1 represents the 95% confidence interval. Means what is this 95% confidence level? Confidence level andre means there is a 95% chance that the hypothesis can be accepted, correct? Means if it lies between these values, the hypothesis is accepted. If it is greater than 1.96, then the hypothesis whatever is selected is rejected. That's it. Clear? You don't worry about all this calculation, but this is required if they ask you to define it. Okay, when you solve the problems, you have to apply this formula, okay, and we will get some value. If that value is less than 1.96, then we can tell that the hypothesis is accepted, and it is accepted how many percentage? 95% of the time it is accepted. And if it is greater than 1.96, then we simply tell that the hypothesis is rejected. That's it. This is 95% confidence level. And one more we have 99%. Okay, so same way, if we get here for 99% it will be between minus 2.58 and plus 2.58. See here, for 95% my t whatever we select, it is between minus 1.96 to plus 1.96. You have to remember these values. But for 99% it is between minus 2.58 and plus 2.58. Means 1%, correct? 99% means how much a percent is rejected? 1%. That 1% means how much? Half percent here and half percent on the other part, correct? So what I can tell, if the value whatever we get when you solve it in the formula, if it is between minus 2.58 and plus 2.58, then we can tell that the hypothesis is accepted how many percentage? 99% of the time we can tell that the hypothesis whatever we have taken is correct or it is accepted. And if it is greater than 2.58, means if it lies here, then we can tell that the hypothesis is rejected. That's it. So this is the way how you have to explain. Okay, draw the diagram. If they ask you to explain confidence interval, if they ask you 95% confidence interval, you draw this and tell that the hypothesis whatever we have selected, if it is between minus 1.96 and plus 1.96, then we tell that the hypothesis is accepted or the hypothesis is 95% confidence level. And if the value whatever we obtain when we solve, if it is greater than minus 1.96 or greater than plus 1.96, then the hypothesis is rejected. Okay, same way you explain it for 99%. That's it. Okay, so this is all about the definitions what they will ask in the exam. So they'll ask you about the null hypothesis or alternate hypothesis, one term. They'll ask you about different types of errors, that is type 1 error and type 2 error, and also they will ask you about the confidence interval. Explain confidence interval. So if they ask you explain confidence interval, what you will do? You tell there are two types of confidence intervals. One is 95% confidence interval and one more is 99% confidence interval. For 95% confidence interval, the area will be lying between the values minus 1.96 and plus 1.96. And for 99% confidence interval, the area will be lying between minus 2.58 and plus 2.58. This explanation you give first. Then you write these calculations. Okay, then tell that once when we solve the problem, if the value whatever we obtain, if it is between minus 1.96 and plus 1.96, then we tell that the hypothesis whatever is selected is accepted 95%, or we have 95% confidence limits, confidence interval. And if the value whatever we obtain, if it is greater than 1.96, then the hypothesis is rejected. Okay, same way you explain it for 99%. That's it. Okay, so this is all about the basic definitions of sampling theory. The problems I'll be doing it in my next videos. Hope you are clear with this one. So whenever you are explaining the hypothesis, null hypothesis or alternate hypothesis, we always you always explain it with an example, then only you can get good mark. And also whenever they ask you errors, type 1 error and type 2 error, there also we expect some of the examples from you. Okay, I had given you the example of coronavirus. Same way you can also think of some other examples. And then this confidence interval, you have to draw the graph and then explain it. That is all what we see in the exam. So altogether these three definitions will fetch you 7 marks. So your second question will be either the definition, okay, either these definitions or the problems related to this one. Okay, so how they you just go through the model question paper, my dear students. You will get an idea how they will be asking the questions. Okay, thank you.